Hello students, welcome back. With this lesson we'll be looking at the mole and how to do mole conversions. So the mole is a unit of measure. It tells us how many atoms there are of a particular substance. Elements are made of protons, electrons, and neutrons. Different elements have different numbers of protons, electrons, and neutrons, causing their masses to be different from one another. So we can't directly compare the mass of two different elements because of that difference. So what we have to do is compare the number of atoms. When we have a set number of atoms, we call this a mole. 1 mole of a substance is equal to 6.02 times 10 to the 23rd atoms. When you have 1 mole of any substance, it doesn't matter if it's gold, iron, hydrogen, helium, you have 6.02 times 10 to the 23rd number of atoms. And that number is called Avogadro's constant, or Avogadro's number. Since 1 mole of a substance is equal to that number of atoms, I can do a direct comparison between different elements or compounds. Later take that idea to predict how much product may be produced or how much reactants will be consumed in a reaction. We can also take moles and convert it to other units of measure, such as volume, mass, molecules, or atoms. So a mole conversion is taking the number of moles and converting it to a different unit of measure. In order to do that, it helps to have a periodic table. On the periodic table, you'll generally see two numbers, a whole number and a decimal number. The whole number is the atomic number. It tells us how many protons there are. The atomic mass number is the decimal number, and it tells us how many protons and neutrons there are in 1 mole. So for example, hydrogen has an atomic mass number of 1.01 grams. That means if I had 1 mole of hydrogen, or if I had 6.02 times 10 to the 23rd number of atoms of hydrogen, it would weigh 1.01 grams. So if I had hydrogen, for example, well, hydrogen's atomic mass number is 1.01 grams. This is for 1 mole, so it's 1.01 grams per mole. That means if I had 6.02 times 10 to the 23rd atoms of hydrogen, which is 1 mole, it would have a mass of 1.01 grams. So 1 mole equals 1.01 grams. So then if I had 2 moles of hydrogen, I should have 2.02 grams of hydrogen. If I had 3 moles of hydrogen, I should have 3.03 grams of hydrogen. So every time we add a mole, we multiply the mass of that element by that amount. Let's say we had carbon. Well, carbon is 12.01 grams per mole. And again, I got that off the periodic table. I found carbon. Carbon's atomic mass number is 12.01. That means 1 mole of that substance is 12.01 grams. So the carbon, if I have 1 mole of carbon, I'm going to have 12.01 grams of it. So if I have 2 moles of carbon, I'm going to have 24.02. I just multiplied 12.01 times 2. So if I have 3 moles of carbon, I'm going to have 36.03 grams. So then if you look at it, if I have 1 mole of hydrogen, it's 1.01. If I have 1 mole of carbon, it's 12.01. So if we're comparing hydrogen and carbon by mass, carbon is significantly larger than hydrogen is. We can't use mass to compare the two. We have to use moles. But before we get into comparing different elements and compounds, we need to learn how to do just a simple mole conversion. We'll just do elements for now and keep it real simple. So let's say I have 2 moles of nitrogen, and I want to know how many grams is that? What's the mass of 2 moles of nitrogen? Well, I need to go to my periodic table and figure out what is the molar mass or the atomic mass number of nitrogen. So I'll look for nitrogen on the periodic table. When I find it, I see that the atomic mass number is 14.01. So if 1 mole of nitrogen is 14.01 grams, then how much is 2 moles of nitrogen? Well, all I got to do is take that number and multiply it by 2, which is 28.02 grams. The method you'll most commonly see to figure this out is dimensional analysis, which goes as a little something like this. So if I got 2 moles of nitrogen and I want to figure out how many grams, I set up a proportion. I put the starting number over 1, and I'm going to multiply that by a proportion. Since I'm trying to change moles to grams, I need moles to cancel out. So I'm going to go ahead and put moles on bottom, and I want grams on top. Well, 1 mole of nitrogen is equal to 14.01 grams. So to figure this out, you just follow your setup. 2 divided by 1 is 2, times 1401 is 28.02, divided by 1 remains 28.02. And that'll be grams because moles cancel out. It's going to be 28.02 grams of nitrogen. Let's do another one. Let's say we got gold this time. We have 5 moles of gold. We want to know how many grams is that? How many grams is 5 moles of gold? So we set up our proportion. I got 5 moles of gold. I stick that over 1. I need moles to cancel out, so it goes on bottom. I want to change it to grams, so that goes on top. So 1 mole of gold is equal to what? We go back to our periodic table. So I go to gold, I find gold. Gold is 196.97. So 196.97. Now we just follow our proportions. 5 divided by 1 is 5. 5 times 196.97, we get 984.85. Moles cancel out. That leaves us with just grams. So 984.85 grams of gold. Pretty simple, right? Let's do another example. Let's do lead. Let's say we got 3.2 moles of lead. And I want to know how many grams is that. The key to remember is this. If you have moles and you want mass, you multiply. It's pretty simple. If you got moles, you want to change it to mass, you just multiply. You multiply the moles by the atomic mass, and that gives you the total grams. So let's set up our proportion so we can figure this out. I got 3.2 moles of lead. Stick that over 1, and I'll multiply that by a ratio. Since moles are on top at the start, I want moles to be on bottom at the end, so it cancels out, and I will have grams on top. Well, 1 mole of lead is equal to how many grams? Got to go back to my periodic table. I find lead is 207.2. So lead is 207.2 grams per mole. So 3.2 divided by 1 times 207.2, and I get 663.04. But we need units. Moles canceled out, leaves us with grams. So 663.04 grams of lead. There may also be times where you got to convert grams back to moles. So let's try one of those. So let's say I got 100 grams of silver, and I want to know how many moles is that. Well, this process is the exact reverse. Instead of multiplying, we're going to divide. So same thing, let's set up a proportion. I got 100 grams of silver. I stick that over 1, and I make my, since grams are on top, I need grams to be on bottom now. And moles are going to be on top. Well, 1 mole of silver is how much? I need to find my periodic table. I need to find on my periodic table silver. So silver is 107.87 grams per mole. So silver is 107.87 grams per mole. So I do 100 divided by 1 times 1 divided by 107.87, and I get 0.93 moles. And it's moles because this time grams cancels out, and that leaves us with moles of silver. Let's do one more of those. So let's say we have 10.75 grams of sodium. And I want to know how many moles is that. Well, let's set up our proportion, same as always. So I got 10.75 grams of sodium. Stick that over 1. Set up my proportion. Grams are on top. I need grams to be on bottom now. And I want to change it to moles. So 1 mole of sodium is what? Let's find on our periodic table. Sodium is 22.99 grams per mole. So we put 22.99 grams, and then we just kick out the math. 10.75 divided by 1 times 1 divided by 22.99, and that gives us 0.47 moles of sodium. Remember, these grams canceled out, leaves us with moles, and there's our answer. Now that we got mole conversions of elements, what about compounds? Compounds are a little bit different because compounds are multiple elements. So let's say we got CO2 and I had 1 mole of CO2. Well, how many grams is that? Well, this time I have 1 carbon and 2 oxygens. So what we do different here is we just add up the atomic masses of those elements and get the molar mass. Just simply break it down first. So carbon is equal to 12.01 grams, and there's just 1 of them, so I multiply that by 1. Oxygen is 15.99 grams, and this time there's 2 of them, so I multiply that by 2. I do a little bit of math. 12.01 times 1 is 12.01. 15.99 times 2, 31.98. I add those values together and we get 43.99. So that means carbon dioxide has a molar mass of 43.99 grams per mole. So that means this 1 mole of carbon dioxide here is 43.99 grams. If I had 2 moles of carbon dioxide, it would be 87.98 grams. I would just multiply it by 2. So if I had 3 moles of carbon dioxide, I would multiply it then by 3, which is 131.97 grams. So what about if we had 5.5 moles of carbon dioxide? How many grams is that? Well, let's just do like we've been doing. Set up our proportion. So I got 5.5 moles of CO2. Put that over 1. I set up my ratio. Moles are on top again, so moles on bottom to cancel out. Now I want to change it to grams, so it's on top. Well, 1 mole of carbon dioxide weighs 43.99. So I do 5.5 divided by 1 times 43.99, and we get 241.95. Moles cancels out, leaves us with grams. So 5.5 moles of CO2 is going to be 241.95 grams of carbon dioxide. You may also have to do that in reverse. So how many moles is 36 grams of H2O? Well, first we got to break down what's the molar mass of H2O. I got two hydrogens. Hydrogen is 1.01, and there's two of them, so that is 2.02 grams total. Oxygen is 15.99, and there's one of them, so that's 15.99 still. So I add those values together, I get 18.01 grams per mole for its molar mass. Now some people will round it, they may just use 18 grams, and that's completely fine if you do. I'm just choosing not to this time. So if I got 36 grams of H2O, and I want to know how many moles is that, I just set up my proportion. So 36 grams of H2O over 1 times that ratio. Grams is on top again, so grams needs to go on bottom to cancel out. I'm trying to change it to moles. So 1 mole of water is equal to 18.01 grams. Now just follow the math. 36 divided by 1 times 1 divided by 18.01. I get 1.99. 1.99 what? Got to include units. So grams cancels out, leaves us with moles. So 1.99 moles of H2O. And that is simple mole conversions. That's moles to mass and mass to moles. Moles can also be converted to other units like volume, atoms, and molecules. But for now, we just wanted to keep it simple, keep it moles to mass and mass to moles. Hope this video helps, and good luck on your tests.